Hello and welcome to Vase Projects. Today I'm going to go through my CAD models that I have for the ButterBot, and then I'm going to show you how I set up the 3D printer with the code. For the first thing I have designed, this is the long link. I sometimes call it the base link. This is the big one. You can see here the male and female connection in better terms. This fits into that, but this will be on the base. And here you can see the double D profile that the stepper cap TM will go into. And I changed the lattice pattern a little bit, as this is easier to print and a little less complicated than what I had before. And there's fillets on all the sides and all that. This is not a double D profile because this is actually a clearance fit. If this was the double D profile, it would drive the same thing and it wouldn't allow for movement. So that was a mistake I made in the initial design. And then these holes here is how I'm going to attach the stepper to it. And that's this link. We go on to the next one. This is the wrist link. Here we have the male connection that fits directly into that female connection on link 2 with the double D. That stepper cap will go straight through this. The lattice pattern again, and I changed where I put the angle. Before I had this going all the way out and the angle just being the slice here, that wouldn't have worked. This actual portion of the wrist needs to be angled, which means this whole thing would need to change in the future if I want to use a different motor, which I'm not happy about, but it's what we have. This is the perfect hole for the stepper. I'm pretty sure that the stepper I bought is going to be able to move the butter knife. There's no real doubt in my mind that I'll be able to do that. So I didn't feel too bad about making this specific for that. But who knows? Who knows what can happen, which is why I'm doing it like this. These holes here are for screwing in the stepper motor, or if this fit is tight enough, I won't have to screw anything anyway. And then this gap here is for the wires to go through. Let's go on to the next one. We have the effector. This hole is what the stepper shaft fits into. This is a small hole. This is not the hole that the stepper cap goes into. And you might notice that this hole is not a double D profile. And that is because my 3D printer has issues printing circles, especially small circles. They're always ellipticoid, or they're like ovals, And an oval honestly fits a double D profile better than a circle does anyway, so it might not be an issue. And even if it is, I can fill up this bit with hot glue and it'll make up the difference. This won't be that heavy. That'll go through there, and then the knife itself will fit into this slot. And that'll be angled, and then this will rotate, this way or this way. So it'll be nice. It'll be nice. And then finally, the stepper cap. Nope. Here we have, this is the diameter of the little circle, that runs up flush with the stepper, and then we have a circular profile where the double D fits into. And again, this is because my 3D printer doesn't print small circles very well, but hopefully this will come out as an oval and it'll work out fine anyway. And you see the double D profile here. This is for one. Later on I can put this same profile just on the other side, so we can have it driven both ways. So with that ahead, I'm going to go ahead and show you what I use or how I do the 3D printer code. You would take something like this. We'll do this one. You would save it. Instead, this is a SolidWorks part file, so you would save it as an STL instead. Go in here, STL, which is like a stereolithography something. Save it there. I'm not going to replace it since I haven't saved it before, but that's what you would do. And then you would open it up in a program called a slicer. I know it's a whole bunch of things, but this is my slicer. I use Ultimaker Cura. It's good for a lot of your personal 3D printers. And here it is. Now, those of you who know 3D printers know this might be an issue and this might be an issue. So we're going to need slicers with supports. And here are the options you have. This is the like the layer millimeters. It's dynamic. I want to be a little bit smaller, so I did 0.16 millimeters, but there's really no difference between 0.16 and 0.2. I'm going to do a 20% infill because I want to be light but still a little bit strong. And I need to do supports. I don't like doing supports because they're kind of hard to get out, but I need to do supports on this one because of this part right here. This needs to be filled in. And then this might need to be filled in because otherwise it would just try to bridge across and it would all be a mess. It still might be a mess with supports, but the supports would be, a little helpful. So if we slice that, that'll give us the G code when it finishes running. And the G code is like the code that tells the extruder on the 3D printer where it needs to move to make this piece out of plastic. 17 hours. If we go to preview it, then it'll show us all the layers it's going to make. And then these little bits here, here, and here are going to be the supports it tries to make. Now this support will probably fail, and this support will probably fail. So it's going to be a bunch of strings here, and then this will be very stringy. But honestly, with this being as tight as it is, it might just be a force fit for the motor anyway. So I'm not going to really need this part. As long as this whole piece is more or less intact, I should be fine. And of course, will be supports here, and that'll be easy enough to get off. And that is how I do it. You would save this to you would have an SD card or like some sort of SD card adapter that plugs into your computer that you would save it to. And then that SD card is what goes into the area. And that's it. See you guys next time.